All right, let's see if we can match this up. This comes from the exercise at the back as well. I will do one of these and then you try the other. So let's go with B. Which one represents B? Number 24, 25, or 26? All right, so if you look at B, we can use either the slope-intercept form method or the standard form method to figure this out. If you use the slope-intercept form, which I think would be quicker doing it this way. If you think the x and y is quicker, that's fine as well. You just see that this is going up by ones, so that means this is -1, -2, -3, -4, right? But you see these are in standard form, so you could use the standard form one. So this is -4, that means my y-intercept is -4. So we know we have y equals to mx plus b, so x subtract 4. And then my slope is up 1, 2, 3, 4 units over 1, 2. So up 4 over 2. So that's going to be y equals to 2x subtract 4. And we want all of our x's on one side, our y's on one side. If you look up here, these are all positive 4's. So that means we want to bring the 4 over to the other side. So we add 4. And you could do this all at once. We've done it enough, so we subtract y on both sides. The 4's cancel. The y's cancel. On the left, you will have 4 equals to 2x subtract y. And so we get the basic equation there. And then now that we have that, we need to decide which type of line will we have. So we have 2x subtract y. If you look up here, there's only one 2x subtract y. That makes it easier. We also know that it's going to be a solid line. Because it's a solid line, that it has to be greater than or equal to. And because it's shading below the y, we could have done that here. Because it's shaded below the y, that would have been y is less than or equal to, because it's all below the y, right? Below, below. So y was less than or equal to 2x subtract 4. So when you brought everything over, right? Remember we brought the y back over and we brought the 4. So it would have stayed as 4 less than or equal to 2x subtract y. Right? So that's what we're looking for. And if that's mixing you up, you can always rearrange it, but just remember it's the less than is pointing to the 4. And so we have 2x subtract y is greater than or equal to 4. And we already had circled that one there, number 4. You could have also done it using x and y intercepts. Some students will find that more challenging because once you figure out that the y-intercept is -4 and the x-intercept is 2, you have to kind of work your way backwards, and that could be a little bit challenging. So sometimes it's easier just to use a slope-intercept form and then rearrange it to see fit. All right, you probably will guess the other one based off of some of the properties of inequalities. All right, so go ahead and try number 25 and 26 on your own. Okay, so example 4 now uses linear inequalities in real life. And so we have practiced how to create equations and inequalities by reading the questions. Now we're going to connect it with the graphing aspect. So here, example 4, we're going to write and use a linear inequality. So you have relatives living in both the United States and Mexico. You are giving a prepaid phone card. This is an old question, like 1995. So you may not know what prepaid cards are, but there's something that we have to use to call international. So you are giving a prepaid phone card with $50. Calls within the continental United States cost 16 cents per minute, and calls to Mexico cost 44 cents per minute, sorry. So you basically have what your expression is going to be. Remember, you could write a verbal model here. Uh, we've done that a good bit, so I'm just going to speak the verbal model. You're going to have your United States, right? United States rate times the amount of time spent. Right, I'm kind of jumping ahead of myself, but it says write a linear inequality in two variables to represent the number of minutes for calls within the United States and for calls to Mexico. So if we start with the United States, we have 16 cents per minute, but we don't know what the minutes are yet, so we say X. And then we have 44 cents per minute, but we don't know what the minutes are, so we could write that as Y. And it's worth $50. Now, you will either use your whole $50 amount or not. But you can use, if you don't use the whole 50 amount, then that means you're going to be using less than the 50. If you decide to use all of that money, then you put an inequality equal sign there. So less than or equal to. So you have now what your inequality is. So now we could go ahead and graph the inequality using the steps we just learned. We can do that using the x-y intercepts, which is normally the easier when it's in this format. Now you could use a calculator to divide that, or you could use your division calculator. But remember, you're going to have to first find your x-intercept. So to find the x-intercept, set your y equal to 0. So you can have 0.16 x times 0.44 times 0 is just 0. So we don't really need to write it. Equals to 50. And to figure out what x is, you're going to have to divide 50 by 0.16. And I'm going to use a calculator there for time's sake. So 50 divided by 0.16 is actually going to make that go up higher. So 50 divided by 0.16 is 312.5, or in 50 hundredths. To find the y-intercept, remember, set the x value equal to 0. So basically you're going to have 0.16 times 0 plus 0.44y. We're going to use equal 50 just to get the y-intercept. Remember, that is not there anymore basically. So same thing here, you're going to say 50 divided by 0.44. So 50 divided by 0.44 is going to give us a recurring decimal there of 113 0.636363, and so we could round that to about 6.4. You could technically round it to a whole number because at the graphical level, it's going to be a kind of estimation when we graph it, unless you really want it detailed, and that's going to take some time. But the reality is, to really find the possible solutions, we don't really need that accuracy. All right, so let's go ahead and graph this. You see that on the x value, I need to go up to in hundreds. And so it'd be easier just to go like 100, 200, 300, and kind of approximate it just above. We only need the first quadrant because we're dealing with positive values. And so we can say, we can skip every one. So that's 100, 200, 300, 400, 500, 600, right? We don't really have to go that far. So that's our x values. Our y's don't go up that high. So you could do your y's by 10. Let's see. If you do it by tens, you're going to have to go up to about 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You just kind of make it there. All right, so let's do that. So this is going to represent 10, 20, 30, 40, 50. Just going to skip a few. 60, 70, 80 is going to be about here. 90, 100, and 120. And yeah, we don't have to go that high, so 120. All right, so 90 is there. 70, 60, and 40. All right, so let's go ahead and mark our spots. 113 is almost halfway there, just below 115. And then 312.5, this would be 350 halfway in. Halfway of that would be 325. So you want it just a little bit in between, about quarter, just a little bit below the quarter line. All right, so then we just connect those two. We connect those two lines. It might have been better using a different color there. All right, so let's use red. So we're going to connect those two. We don't need to draw beyond because they're restrained by you can't go back in time, and we're not going to go in negatives amount there. So we don't have to draw any arrows. Our domain is kind of fixed and our range is fixed. All right, so we have our line there, and now it asks us to discuss three possible solutions for this real life situation. So first, let's see, where would we shade? What would represent the inequality there? Well, we use our inequality here to assist us. You can either substitute a point in to see if it passes or fails, as the book shows, but I like to just use the slope intercept method. You can see if you brought that 0.16x over, you have 0.44y is less than or equal to 50 subtract 0.16 hundredths of x. All right, and so you can see if you used to divide by y, you're going to basically have that everything is less than or equal to the y. Everything less than or equal to y means that if you just chose the y-intercept, you're choosing everything down from the y-intercept, which would mean your boundary or your shaded region would be bounded by the x-axis, the y-axis, and the line itself. And so that's our shaded region. So that means anything in there will satisfy. And I can now choose different solutions to help me in this real life context. All right, so let me erase this thing up top here just to show you how we can do that. So let's say I just choose two random points. Those two random points represent two significant things. Now on the x-axis, we want to label that. Our x-axis represent calls in the US. So that's the US time, right? Because that's what x represents, time in minutes. And on the y-axis, that's Mexico, and that's time as well in minutes. Okay, so if I choose a random point in there, let's say I choose an easy point that can be found, right? So that's my x value there. I write it up here. My x, I have 100 for my x and 30 for my y. That means if I was to use that I have 100, if I spent 100 US minutes and 30 Mexico minutes, I will still have money left over, right? Because it's in that region. And we could substitute in there to see, does it satisfy the inequality? And so if I put 0.444 times 30, that should give me an answer that's less than or equal to 50. Now 0.16 or 16 hundredths times 100, you just move the decimal point 2 times, that would be 16. 16 plus 0.44 times 30, 13.2. And you see there, if I add all that together, I'm going to get a nice easy number there. And so $29.20 would be used, which is less than or equal to the $50 I have. So you can see I can use this to kind of come up with an idea. Now this is good for when you're dealing with large amounts of data. You can put this information into like an Excel sheet or any other type of program and work out all the possible things that can happen. And you can, sometimes we encounter programs like that that will let you know you can't do this. That combination won't work. Right, so that's a example there. You could spend 100 US minutes with 30 Mexico minutes. You can even get right on the border there. Right, this is should be work out right. You could spend, I think that's 40, right? 40, or let's go in XY order. You could use 200 US minutes and 40 Mexico minutes, right? You could even go to the very top. You could just spend 100, what's that, 100 Mexican minutes, right? Just below that. Or you can actually use the y-intercept itself. But any combination of x and y that lands on the border or below will satisfy that. And so those are three possible solutions that it refers to.